All right, so what would be better, right, than degrees? So the answer is this thing called radians, which is sort of tangentially where pi comes from. Let me give radians first, and then we'll talk about pi. So I'm assuming you guys know how far around a circle it is. So let me say, here's a circle of radius 1, right? So if this thing is laid out on the ground, right, obviously I could measure how far it is around it.
2 pi.
It's 2 pi walking around it. You guys see that? That distance is 2 pi all told. Okay. So here's how we're going to measure angles. We are going to say, here's a slice out of the unit circle. This is radius, out of a circle. Radius, radius. There's some length here. I'm going to call this length S. You guys see that if I tell you a radius and a length, that makes an angle? You see that? So I'm going to define theta, which is going to be measured in radians. And this means I'm defining, right? So this is going to be equal because we said so. But of course, this is a good, this is a because we said so for a reason, right? And I'm going to do what? I'm going to take that sector length, and I'm going to divide by the radius. You guys cool with this? And that's really all there is to radians. Cool? Now, I should probably mention, I don't know, what some angles are, right? So let me play this game for a minute. If I told you 2 pi, and you may as well think in a unit circle, right? Okay, see that? May as well call the radius 1 while I'm just thinking. So 2 pi is this, right? All the way around. So what's the angle that goes with all the way around in our old, horrible Babylonian visuals?
360.
360 degrees. Okay. What if I wanted to go 90 degrees?
Pi over 1/2 pi or pi over 2.
Okay, that'd be a quarter of the way around the circle, right? So that'd be, all right, here's my 90 degrees, right? Now I'm asking, how long is this?
1/2 pi.
That's half a pi, right? Because it's 2 pi all the way around, and I'm only went a quarter, so 2 pi split 4 ways is pi over 2. That's cool with us? All right, conversion factor. Okay, so if 2 pi is 360 degrees, what's 1 radian?
No, that's 1 pi.
Okay, so 180 degrees, right, is
1
pi radians, right? That's halfway. But what's 1 radian?
180 over pi.
Ah, it's 180 over pi. You guys see this? Okay, so let me write that this way. Now this gives you a conversion factor. Okay? This thing here. I'm not so concerned with whether you know this word or not, but you should know the feeling of this thing. You guys want to know why you know the feeling of this thing already? Okay, let me say you have 7 feet, right? I want to know how many inches this is. What do you do? Multiply by 12, right? Why are you just willy-nilly multiplying by 12? Yeah, because 12 inches divided by 1 foot is 1, right? You guys see that? That's multiplication by 1, which is something I'm allowed to do. You guys see that? The feet units cancel, I get inches out, I get whatever 7 times 12 is. You guys cool with this? This is the same tool as that 12 inches in a foot. This is telling you there's 180 degrees in pi radians. It's cool with that? Okay, so let's go back and convert our usual things. So what are our usual angles?
30, 60, 15.
Okay, let's see. So I should be able to convert 30 degrees, 60 degrees, 90 degrees, 0 degrees,
45.
and 45 degrees. If I can't convert these back and forth, I should probably quit the whole deal, right? Okay, so what's 90 degrees in radians?
1.5.
That's pi over 2. We just did that one, right? What's 0 degrees? 0 radians. Okay, now these are going to get slightly harder.
45 is pi over 4.
45 is pi over 4. Why should it be pi over 4?
It's half over pi over 2.
Yeah, because 45 is half of 90, right? And pi over 4 is half of pi over 2. Okay, these I might need a little bit of side calculation, right? That one's pi over 3. Yeah, it's a third of the way to pi, right? It's a third of the way to 180. Okay, see that? Or, if this is going over your head a little bit, you can think, okay, I've got 60 degrees, right? And I want to multiply by this thing with degrees on the bottom. So I want 180 degrees, so the little dots cancel. And what do I have to put on top? Pi, because I can't multiply by something other than 1, just willy-nilly, right? Gotta have a reason. You guys see this? So I'll get, let's see, 60 goes into 180 3 times. I think that gives me pi over 3.
So 30 is pi over 6.
And 30 is pi over 6. Cool with this? So I personally would recommend that you put this conversion and this conversion factor in your head. I will switch back and forth between these without mentioning what I'm doing. Okay? Sometimes it'll be more convenient for us to work in degrees because, I don't know, maybe addition and subtraction are easy there. Sometimes it'll be easier for me to work in radians because I'm trying to do more complicated things like sector lengths, right? Which are going to be dead easy in radians and are really complicated in degrees. You guys cool with that? So depending on the application, I'm going to switch back and forth between these. Cool? All right. Any questions, concerns?
So can we also do like pi over 12 for considering the whole thing and just consider whatever section we're at as whatever number
Sure,
it
yeah.
is?
That's a fair question. What's pi over 12? So pi over 12 radians is, what do you multiply by?
That's 1.
So I've got pi over 12, and I'm multiplying by
180 over
1, right? But degrees should go on the top or bottom? Top, because I want degrees out. Over pi. The pi's will cancel, right? That's a onesie. And what's 180 divided by 12? I don't know.
15.
13. You guys see the facility of using this? So we can convert back and forth from one measurement to the other. I would recommend that you try to live in radians where possible. They are actually, there's a better reason for their existence. But sometimes degrees is, you know, what you're used to. You're going to have a hard time finding a protractor listed in radians. Cool? Questions, things? All right.